Test. Okay. Hey, folks, we're going to start up again here in a few minutes. We're in the home stretch, so let's head back to our seats. Okay, thanks. Let's get started again. So I think, we've talked a lot about different ConOps or, sort of in general. And I think a lot of you have probably seen the WISC ConOps that was published 2 months ago? Almost 2 months ago. And we're lucky enough to have Eric here to talk to us a little bit about what's contained within that ConOps. Thanks.
So the important news, if you haven't noticed, the US won. So World Cup, go. The lunch was perfectly timed, by the way, I should say. But now onto business. So a couple of months ago, I was on a panel with Andy Latcher and Brandon Suarez on the subject of digital flight rules. And one of the things I want to convey is I believe, and I stated there, that we absolutely want, as an industry, to go towards digital flight rules. And this conversation of one-to-many, right? I think one of the underlying messages is the more digital we go, digital flight rules, the higher number of M2N will become a reality. This is, and the reason I bring up digital flight rules is because it conveys this idea of an ecosystem. It's not about defining an aircraft, it's about defining a system. Now, along these lines is, where does this ConOp that I'm going to be speaking about fit in? This is a ConOp that can enable and demonstrate one-to-many operations in today's NAS with some surgery, okay? And that's what this ConOp is. During the presentation, I will even make the case that the elements, and borrowing from our industry's crawl, walk, run, what this ConOps proposes is a framework to start testing all of the elements necessary to achieve digital flight rules, but with training rules. Okay, so it's a springboard ConOp. If you ask really hard questions, my wingman is in the back, Jeremy Carver. He's part of this conference. So if you're with him in one of these breakouts, please do ask questions, the hard ones to him, of course. So a little bit about WISC. WISC is a joint venture. We are supported and working very closely with the Boeing company. Right now, we're crossing, if we haven't already, 500 employees, combined Boeing, WISC, and Boeing, and we're hiring. That's a plugin. Go check us out. We recently revealed our 6th generation aircraft. This is the one that we're going to market with, and this is the one that this ConOps that I'm going to be speaking to about aims to open the door. Right, so the 5 aircraft that you see on the top, these were our R&D experimental aircraft. The 6th generation one is 4 passengers, a payload in sufficient for 4 passengers, and so forth. So the ecosystem, right? So as we think about one-to-many, part of the trick is how do we remove entropy from the system? How do we increase predictability in the system? So when we look at the ConOps that we're proposing is we're looking at a fixed route network, urban taxis. So these aircraft will be going from this point A to point B and back, continuously. Maybe there's a point A to point B, point B to point C, but it's always the same routes, such that the predictability of these routes is, and everything that can happen along the routes, right? So contingencies, alternate landing sites, et cetera, are well defined and understood. Within an urban environment, within a mode C, right, we will be relying on surveillance data as a means of further enhancing this visibility, right? So unlike the former, the regional, if you will, use case that was presented just a few minutes ago, within an urban environment, we have the benefit of being highly sensorized, or where we have gaps in visibility, add that information to create that visibility for us. So our aim is for having several of these aircraft over an urban environment, just like Chicago. Okay. Why now? Well, I mean, for the same reason we're having this conference, right? So we have a convergence of sensing and compute technologies. We have electrification. If you're in hydrogen or any other fuel, welcome. But for the case of WISC, we're all about electrification. C2 links and data infrastructure are everywhere. If you don't believe me, the folks this morning were having a heart attack because they couldn't connect to the internet, right? So data and information is ubiquitous. We have Aura networks in the crowd. And so now you start to see that the ecosystem is starting to build. And I would argue that regulations and standards are also coming to the table, right? Look at this conference, one-to-many. It's defining the standards around one-to-many. So why autonomous? There's a safety angle and there's a scalability angle. On the safety side, you know, flight computers with their dissimilar technologies, distributed electric propulsion, these avionics have achieved and demonstrated levels of reliability that you know, exceed any human capability. At the same time, we have information systems that are ubiquitous, that enable us to have situational awareness on the ground that exceeds the situational awareness of an individual in the flight deck, especially in the types of urban environments that we aim to deliver our services in. So then let's go to the one-to-many, right? So I shouldn't explain to anybody in this room what we mean by scalability and the pilot shortage, right? That is central to the one-to-many argument. But then there is the operating cost, and there was discussion earlier this morning about what is the optimum one-to-many. And I would argue that it's a, you know, Econ 101. The more we're able to reduce the operating cost for these aircraft, demand will increase. So it's not a number, right? It's an operation. And to the extent that we can reduce the operating costs for these aircraft, the uptake will increase. And so it's a surface. So now, what do we mean by autonomous? All right, let me break down the marketing. Autonomous is the aircraft handles left, right, up, down, and throttle, right? All of the aviate aspects of the aircraft are handled. The human oversight comes in the form of navigation and communication, right? So again, to the extent that we can minimize communication, we increase the capability, the cognitive abilities of humans to handle additional aircraft. Thus, the push for digital flight rules is important. So this is the document that we published October 21st. It was published jointly by the Boeing Company and WISC. It can be found on both of our websites. And it clarifies that it's focused on IFR operations. Read the document, right? There is an understanding that there will need to be some letters of agreement in order for this to happen. It includes both controlled and uncontrolled airspace, but it doesn't include vertiport protection volumes, PSUs or certified widespread use of PSUs or digital flight rules. Okay. Level of autonomy. Again, nobody on board. The aviate component is handled by the aircraft, and navigation and communication oversight by the humans, and we would be operating under Part 135 ticket. So what are the key enabling elements? So we have C2 links, we have vertiports, but when you think about vertiports, it's more than just a slab of concrete, right? When we talk about vertiports, we're actually talking about an information system, a vertiport automation system that enables these aircraft to coordinate and do flow management coordination with that vertiport. So there's an information layer. There's an information layer in the C2 links. There's an information layer in the vertiports. And God knows that there's an information layer with the operating picture, right? Operating picture, meaning this could be a service provided by the PSUs or what have you. Essentially, the situational awareness that is provided to participants. As it pertains to this ConOps, we would be leveraging IFR routes, preferably TK routes, taking advantage of the helicopter modernization efforts. And this is where we start getting into tweaks that will enable us to minimize the interactions with ATC. And this is, if you go through the ConOps, we talk about 4D flight plans or 4D trajectories or trajectory-based operations. And the idea is all of the information in the system is available for both the FAA and as a third party to look at what trajectory I'm going to fly, understand if any other aircraft will be traversing that airspace, and thus understand whether or not I have a fully deconflicted route. If I have a fully deconflicted route, what that means is now my paradigm with air traffic control in principle can be, they will know where I'm going to be, and thus they can manage me by exception as opposed to actively control me. If they're monitoring or controlling me by exception, I've already reduced the number of interactions with air traffic control on voice, and thus I can preserve one-to-many capability. It may not be 1 to 10 or 1 to 20, but I'll be able to maintain some one-to-many capability. And then the last layer, when we were talking about, earlier this morning, the gentleman from the FAA talked about detect and avoid, is the last layer of protection is an onboard system for detect and avoid and landing hazard avoidance. Prior to that, we looked at route design, that it was deconflicted. Then we did strategic planning when we launched the aircraft. Then we did, the operating picture was providing operational separation. And then lastly, we would have tactical separation, just following the ICAO framework. So let me speak to what I mean by providing or putting forward an architecture that enables a crawl, walk, run, basically exercising what would be needed for digital flight rules in today's NAS. So every single time I present this to executive leadership, I get scolded because there's too many words. So my ask is don't look at the words, look at the colors. If we were to go and operate today in the NAS under IFR, I would have a fleet operations center, a dispatcher, file a flight plan. That flight plan is accepted, the crew takes it, and they go and they operate in the NAS. At that point, it's the two parties that are interacting are that aircraft and the air traffic controller. Now, if we look at, does this thing have a laser? Yeah, it does. So if you look now at the blue, which is the delta, and you look at what we would be asking from the Fleet Operations Center, which effectively now is also controlling the aircraft, and air traffic control, is if we enable this single clearance, thus ATC is now controlling us by exception on this 15 to 30-minute flight. The impacts on ATC in the grand scheme of thing to the existing system are contained. The rest of the system, however, so on the fleet operations side, some of the functions that ATC would typically do are also now being mirrored by the Fleet Operations Center. So we would have self-provided separation services and flight monitoring capabilities, leveraging the PSU capability, right? And so now I'm starting to exercise how it would be to operate under PSU control. The Fleet Operations Center is communicating with the aircraft via C2 links, highly reliable and redundant. And you'll notice that the communication with the Fleet Operations Center and the vertiport does not go through ATC. So the coordination with that entity, as it is today, by the way, with any FBO, if you're flying a helicopter, is not with ATC. So the flow management to and from the vertiports are directly coordinated by the operators. So this ConOps, what it does is it presents an environment where all of the elements required to operate under digital flight paradigm are starting to exercise under IFR with air traffic controls oversight. We can exercise every aspect of the system such that at some point, ATC, that top right block, is replaced by digital flight rules. And this is where I go back to the comment that I made a couple months ago in New Orleans with Andy Latcher, is what this ConOps does is it provides the roadmap to get us through to the next phase. Okay. So as we look at this, this is where we are today. This is where this ConOps, the midterm, later this decade is aiming to define, such that we can very quickly go into the far term, where we have digital flight rules, higher M2N ratios, and what we mean by this is we're also able to reduce the operating costs and make this a more viable service for the community. So with that, I'll take questions.
Hey, thanks, Eric. Quick question. When you briefed the ConOp before and you had the fleet dispatcher talking directly to the vertiport and you mentioned the operators were communicating with the vertiports. Is that scenario right there supportive of having more than one operator using a vertiport, or is this only for like a vertiport dedicated to WISC, for example?
Great question. So at the very beginning, as part of this crawl, walk, run, we would be looking to have exclusive use photos, right? There are a couple of reasons. 90+% of all helicopter operations perform VFR landings and have the visual segments. And they don't even know what a vertiport automation system is. And so the reason why we would ask for exclusive use photos is we want to demonstrate that the vertiport automation system and this integration works, one. And two, we believe that there's sufficient market to keep that vertiport busy, right? So make sure that that investment is well spent. Now, remember, if you transition to digital flight rules and other participants are leveraging that same vast API, now you're looking, everybody is coordinating and doing the flow management into those vertiports in the same manner. And that's when it makes sense to make it interoperable. So that's why we at WISC, we believe it's so important to help define these standards for VAS interoperability and what have you.
I'll ask one then. I love this. I love getting, putting a stake in the ground and trying to move forward with it. What you talked about here is really, in a lot of ways, when everything's working. And I think, what I had mentioned before, and what I think has been a theme here is that when things fail, when interventions are necessary, have you thought about contingency management, cascading failures, how that would be handled within this?
So there's 500 people thinking about that. But yes, so, one of the responses that came from previous panelists was, in a contingency, will you maintain one-to-many? Likely not, right? In a contingency scenario, you're back to one-to-one, making sure that that aircraft gets all the tender love and care. One of the benefits of having and operating on a fixed route network is you have visibility of a lot of advanced planning into, if something happens at any point in that trajectory, where are you going to go? And so, yes, the answer is yes, we're thinking about it. One-to-many, we believe, is when things are operating correctly. In a contingency scenario, you would do teamwork, offload somebody, similar to how you would do air traffic controllers, one person controlling that aircraft. So Brandon has a question because I mentioned his name, so.
I was just curious how having people on board impacts the dynamics that we've been talking about today, in terms of, you've got sort of another actor in the system that can, I assume, tell the aircraft, hey, can you land as soon as possible? Hey, I'm not feeling great. Can we land now? Hey, I gotta go to the bathroom. Hey, the baby's crying, whatever.
So WISC is not considering having a human on board, so I don't know. Oh, okay. Yes. The folks with a central nervous system that are on the aircraft, yes. Great question. So in the ConOps, we also introduce a persona called the hospitality manager. And the role of that individual is to ensure that that passenger feels safe, and if anything, feel safe and comfortable. And if anything happens, they're the first line of intervention. It could be as simple as, everything's fine, you're doing perfect, right? We'll have your mocha ready when you land, or whatever it may be. But if something else is more relevant, as in somebody's having cardiac arrest situation, then the hospitality manager, who we've at this point, we've maintained the acting PIC, leveraging this sterile crew or flight deck effect, concept. At this point, the hospitality manager reaches out to the multi-vehicle supervisor and says, we have a situation, we need to land. And that individual, the multi-vehicle supervisor, is then responsible for taking action if safe and all those things. And then the hospitality manager manages the response to make sure that that passenger's well-being is top priority. And so there we have a fleet manager who helps plan the flight. We have a multi-vehicle supervisor who executes the flight in a one-to-many paradigm. And then we have a hospitality manager that also manages several aircraft and looks over the several passengers. And passengers will have the ability to communicate with the ground at any point in time, and vice versa. Thank you.
Okay, we're going to start moving into a little bit about why we came in terms of the working groups. Wes is going to come up and give us some background context. And just because it's come up so much, I should mention that tomorrow Wes will be talking about digital flight rules. And so maybe he'll give a little.
Yeah, we made a little bit of a change to the schedule. Andy Latcher is actually going to brief the digital flight stuff because you guys are probably tired of seeing me up here. But so I wanted to come up kind of as a closing segment to the day today and really get back to initial purposes and kind of reiterate the reason we're here. And when Kelly Hashemi and Jay talked to me about participating in this, NASA has this need, in my opinion, to provide leadership to industry and to the FAA, and really to create a vision, because there are things that industry can't do alone. There's things that the FAA can't do alone, but NASA can be the dreamer. We can be the ones who look out ahead. So that the goal really was to look at not just aircraft technology, but operational concepts, airspace integration, in the context of expanding end-to-end operations, and how would we move forward, as we've already mentioned several times and we've heard throughout the presentations through the day, identifying the gaps and barriers to that expansion. And so what we're going to be getting into eventually through the process of these workshops over time is to create some type of a roadmap that has some tangible steps in it. And it's not to say it's an evolutionary approach, a crawl, walk, run, but it's how do we get from where you are today operating in certain ways to what you envision as an industry to that future state, and how can NASA help? It's really what we're looking for, because we can propose ideas. You heard research results here today, and there's many other research efforts going on within NASA to support this. But industry also needs to be, involved and kind of be the masters of your own destiny. So it's a group of collaboration. So what we're trying to do is to look in these subgroups tomorrow into how each use case or type of operation might evolve. And so I used the charge for the subgroups that I'll say your missions, should you choose to accept it, is just to look into defining what your near-term vision is, and then what your far-term vision is, and then what does it take to get there? Really ask yourself this question: what does a mature operating state look like in your dreams of what M2N would look like for your CONOP? That could include the ratio of aircraft. It could include the role of the participants that are involved in that operation and the roles that they play, whether it's a hospitality manager, a pilot, an operator, whatever we want to call them. And most importantly, the assumptions around that, to try to document those within the subgroups. And the big thing is looking at your long-term vision, and then what capabilities would get us there. What new capabilities, new technology, new function, new data sharing, what backbone is necessary. And digital flight has come up several times. It's certainly built into a lot of that. And so it's kind of defining this roadmap of how to get from one epic to another. And I use the term epic. You probably have seen this little chart I've used before, but these little hockey pucks that kind of represent the different ops use cases. The idea is that there's a greater operational integration and risk of use on the vertical axis, and a growing capability maturity on the horizontal axis. And we want you all in the subgroups to ask yourself, what does success look like within your epic, within your use case? What is the level of operational integration and other pieces of that puzzle? Also, what lessons learned do you have that might be useful to others? So if you looked at them together, you could kind of envision each one of these little pucks sort of rising vertically within its own use case to be more mature, to expand operations, but that you can also think of them being related to each other somewhat, whether it's the ops integration lessons learned, technology maturity, or the applicable regulations and standards. Each group is learning as they go, and so these things are sort of related to each other, maybe identifying enablers or gaps between them. And that's really the gaps that we want to identify, because we're looking for areas where collaborative research can help. So that's sort of a setup to, or maybe a framework within which each of the subgroups can work tomorrow. But to summarize it, or to be, real succinct, we're really just asking, what does your mature use case look like if you were king for a day, queen for a day? And how would we get there? And specifically, how could you build from what you have now into some future state? So Jay is going to come up and close us out for the day and do a little translation, but look forward tomorrow to Andy's talk on digital flight. Thanks.
Okay, thanks for hanging in there, everybody. We are going to call it a day. And we are going to have an optional happy hour. I guess it's always optional, I suppose, at the golf club, which is sort of just around the corner from us here. So if you Ubered in and need to ride share with somebody, let us know. Otherwise, it would be great to see you over there and have a beer. Thanks, Jonathan and Bree and Greg and all the staff that put everything together. So thanks very much.